So the second session in this technical track, we will be introduced to the containerized world of OpenShift Virtualization. So I hereby hand over to my colleague, the solution architect, Magnus Glans.
Hello everyone and welcome to OpenShift Virtualization, the musical. Future Insight, Virtualization in Kubernetes. I am here with my colleagues Ilka Tengvall and Johan Odell, and I am Magnus Glans. Let's start by talking about the context in which this new technical development is happening. Even though we have enterprise architects, IT architects, solution architects, application architects, our IT landscapes are not a result of detailed planning. The only constant is change. And change happens across all areas that we work in. Application architecture, how we package things, how we deploy them, the infrastructure that we run on, and how we work. The reason why our IT landscapes are not a result of detailed planning is that few companies can afford wholesale migrations to whatever new thing popped up in the IT ecosystem. For example, migrating all applications in a company from one application architecture to another requires enormous amounts of funding. And this is money that few companies are ready to invest, as I said. Now, this means and leads to the fact that few IT landscapes looks like this, only featuring the most modern of technology and ways of working. And it leads to most IT companies' landscapes looking like this, a mishmash, if you will, of different application architectures and technologies that have been deployed during the lifetime of that company, and where each implementation leaves a trace in the landscape. Now this leads to the problem, and the problem is that we end up with very many different applications that has many different requirements, use different languages, databases, application servers, automation tools, infrastructure platforms. And as we add items to the IT landscape, we push up complexity more and more and more and more, until we come to a point where it starts to hurt our business. Where it comes to a point where it starts to cause our IT projects to fail, because we fail to map the project requirements to the technical capabilities at hand. And where it causes IT systems to fail because, well, we cannot wrap our heads around how to implement them. So the science behind this is quite interesting, so you should be reading up on that. But let's talk about containers. And you might think that this is me sticking my head out a bit, but keep in mind, for example, mainframe technology, as an example, was implemented 60 years ago, and it's still not been fully replaced with something else. So it's time to start to simplify. Virtual machines and container technology is gonna live side by side for a very long time to come. And instead of this, where depending on what application architecture and what kind of packaging you might choose, where you have different platforms then, you can have this, a more simple future. This is our aim for you, to have one platform where you can manage and deploy both virtual machines and containers. And I'm sure, of course, you're super interested to know how this looks like. So with that said, I'm going to hand over to my colleague, Johan Odell. Johan.
Yeah. Hi, everyone. My name is Johan. Thank you, Magnus. And I hope everyone has recovered after Magnus' fantastic introduction here. I'm going to jump over and show you how this could look like. As you can see here, I'm logged into OpenShift, and first I'm going to show you how we can get OpenShift Virtualization running in here. And that's pretty easy, actually. We are utilizing operators. So the first thing I'm going to do is to head over to Operator Hub and just search for virtualization. So let's see. Yeah, there we can see we have OpenShift Virtualization. And if you're not into operators yet, easy explanation is that it's basically Kubernetes native way of doing automation. So with operators, it can help you to do a lot of day one and day two operations. And this one can help you to do installation, upgrades, and basically manage the full life cycle of OpenShift Virtualization. But in sake of time, we have already done that, just like any good TV chef. So instead of doing the installation, I'm just heading over here now to show you what it looks like when it's installed. So here we have it. And if I click the OpenShift Virtualization operator, we come into this view. And it's basically just a one button click to set up the entire control plane of OpenShift Virtualization in here. And of course, we do it in a cloud native way. So we will deploy all the technical bits of OpenShift Virtualization into pods, and we put them in one central place in one project. And you can see them all running in here, things to control networking, storage, and whatnot for your virtual machines. But let's instead have a look at the virtual machine running in here. So I'm going to a project, Forum Demo VM, where I have a virtual machine running. And if you look on the left-hand side, under workloads, we have a new menu item called virtualization. So I click that one, and it will display my VMs in this project. I only have one, and I click that one. And here we can see some overview. We have utilization metrics, events, and so on. But I zoom into the details, and here you can see that we can actually apply Kubernetes labeling onto virtual machine and then reap the benefits of Kubernetes scheduling, like node selectors, tolerations. And as we are used to with virtual machines, we can also work with affinity rules or anti-affinity rules. Another interesting part in here is the pod, the Virt Launcher pod we have in here. It's basically that pod that is running your virtual machine. So, as you know, pods are isolation units, and they isolate processes for an application. In this case, our application is virtualization. So if I look into the pod in the terminal, you will see that we are running some familiar virtualization processes. We see QEMU, KVM, libvirtd, which has been around for decades. We are using it in OpenStack, Red Hat Virtualization, RHEL with KVM, and it's also available in many different public cloud offerings as well. So the new thing with this is that we are letting Kubernetes handle the scheduling of the virtual machines. All right, so let's go back to that virtual machine again. We can see some other things in it. So let's look at the console, for instance. We have a console interface. It's mostly for administrative purposes, but yeah, we can log in here. So just for you to see, but normally you would use the same type of protocols, display protocols to work with remote machines as you would do in any other virtualization platform. We can look at some of the network interfaces. We can add multiple interfaces. So here we can see we have two, one attached to the pod network and one to the external world using a bridge. And here we start to see some of the interesting things. Disks we can see as well, but we can do other tasks such as stop, restart, clone the virtual machine, and other things as well. One thing we can do as well is migrating the virtual machine. In this case, we have shared disk, which means that we can do a live migration, and that's just what I kicked off here. So you can see that the virtual machine is now running on worker node number 2. And what we're doing now is that we are moving it to worker node number 1. This can be done, as in this case, we trigger it manually. Now you can see that it's on worker node number 1, so it has now moved. But this can also be done automatically. So for instance, when you're doing node maintenance and so on, you can make sure that all VMs running on a node is migrated away. Okay, so if we're going to look at, if we want to see how we can get new VMs into the platform, we can use different methods. So we can create new VMs by using templates. So here I have some templates of different flavors and sizes. These templates are also available from the developer console in the catalog. You can also just create one from scratch with a wizard, or you can do it the Kubernetes way using a YAML file. But we can also import virtual machines from external virtualization platforms like VMware or Red Hat Virtualization. And then you just hook up to the management interface of that platform and drill down to the virtual machine you would like to import and do that. If it's VMware, of course, we will convert the virtual machine format to fit into KVM as well. Okay, so this was a Linux VM, but we also support other virtual machine flavors. And yes, we do support Microsoft here as well. So we are working with Microsoft in their server virtualization program, where other vendors can certify Microsoft operating systems on their virtualization platforms. So we have certified Windows Server 2012 R2 up to the latest release of the Microsoft Server operating system, as you can see here, running in OpenShift, Windows Server 2019. Okay, but everything you have seen so far is what you would expect from a virtualization platform. When we start to converge and run pods and virtual machines in parallel together, there it starts to be very interesting. So we have an example in here, an application that is split up in different pods. So we can see here we have Cake PHP, which is the front-end interface, and it's communicating to a back-end database. So we have a MySQL pod running the database, and we also have a virtual machine running in the Vert Launcher pod. So here we have a database running in a virtual machine as well. And we connect those different parts through services, of course. So we have the front-end service, Cake PHP. It's always communicating through MariaDB service towards any of the two different back-end databases. And if we look at it in a topology view, it might be easier to see. Here we have the front end, and I'm opening up the UI. Here is the front end interface. And this web is reading through a database table running at the moment in a pod. So you can see those two values in the top left corners are read from the backend database, and now it's from the pod. So right now, here is where we have our application, but we're going to change it to go through the database in the virtual machine instead. And we do that by working with the service. Right now, frontend is going through MariaDB to the MySQL service, and we're going to change it to go to this service instead, the MariaDB VM service. So let's have a look at that. I'm just going to change project to the right one, forum demo. And then we're going to have a look at the MariaDB service itself to see how it looks. And we should see that it's pointing towards the MySQL database, the pod. Yes, there we have it. Now, I'm going to patch this service to point towards the virtual machine instead. And I'm going to do it in flight. So this is how we can do that. Okay, it's patched. Let's verify as well. Yeah, and here we can see that it's up and running against the new backend. Okay, so let's jump into the web interface and do a refresh. And yes, here we can see that we are now using the backend database running in a virtual machine instead. So yeah, this is a simple example application, but can you imagine how powerful this is when you are going to refactor your applications or add new functionality to an existing application with pods? Imagine having the same toolkit, the same tool chain available for both virtual machines and pods in the same network, utilizing the same pipelines and everything. This is when the convergence of pods and virtual machines in the same platform will become very powerful. And this is one of the use cases. And I'm going to hand over to Ilkka to talk more about other use cases as well and where we are heading with this platform in the future. So over to you, Ilkka. Thank you.
All right. Hi, my name is Ilkka Tengvall. I'm the previous guy's colleague from Finland. And thanks for the demo. It's a good example how to combine VMs and containers. And let's look a bit what are the use cases. I think we already covered some of these, but quickly, the first that comes to my mind is lift and shift. You have some old application sitting somewhere in the VMs. It could be something you are running some whatever, Oracle Java, IBM Java. It could be Windows machines. It could be anything that you can virtualize. And then you would benefit of taking that very same service within your pods and you develop all the new stuff into the pods around your VM. That would be the use case that first comes to my mind for this. And also it's a matter of getting test environments. It could be that it's not so easy in your test environment to set up networks and virtual machines and containers and make them talk together. But within this system, you can have them both easily at hand. And especially now this Windows app seems to be a case that I've heard several times in the past. And let's face it, everybody has been young. It could be you were young, you were out of the money, you just had to do what you had to do. You might have been coding Windows applications. That's all right. We all understand that now, being adults. And you can get over it just by bringing the virtual machines into next to the pods, and everything is fine. That's good. So that's the one use case. The second use case is when you want to refactor, like Johan already said, that you take the elephant into pieces, one small piece at a time. So you bring in the VM and you extract one service out of it and move it to containers, make it talk with the rest of the systems. You grab the next service from the VM, move it to, you refactor it to be microservices in containers, and again, connect back to the rest of the system and so on until you have eaten all the elephant and you can bury the VM and you are now fully running in virtual machines. In pods, and you fully get rid of your virtual machines. Okay, so this is the second case. And what is there for infrastructure owners? Imagine that you are the one who people ask for rapid delivery of VMs and containers and how to open the firewalls between them and how to share the storages and whatnot. And now you're able to serve them from one platform. It's easy life for you. Hey, you, the third guy in the internet, I see you are browsing emails. Stop that. This is not for you. So yes, you infrastructure guy, now you can give them from one shop. You get both the containers and VMs and it's easy for the users. That's the use case for infra people. Okay, so what else is there? Let's look a bit backwards. So where did this all come from? So Kubernetes has been around roughly 5 years, and it's been extended now to have this Kubernetes API now has these very virtualization features added to it. So it's the very same API with added virtualization commands. So whatever you have coded for your containers, you can just extend that API usage with for the virtual machines. And now this Kubernetes being roughly 5 years old, and let's look back at the history that in the Red Hat Summit 2018, Red Hat released the KubeVirt as part of OpenShift. It was like mentioned that this is about to come, and it's only now GA this summer 2020, but it's been cooking for the years, and it's part of this cloud native foundation, CNCF foundation, under that umbrella. And what's behind KVM? So let's say that this KubeVirt is roughly 3 years old, but the KVM, libvirt, and the Gemu and the other parts that we're using there are already like teenagers. They came about 2006, probably 2008. Red Hat already bought Comra.net, and it became part of Red Hat. So we've been doing Red Hat virtualization. We've been doing OpenStack for years with this very same technology. So it's proven technology, it works. It's just wrapped now differently into a container to bring yet more security levels, and how do you manage and how do you package the stuff and how do you consume it through the APIs. That's the new part. So this picture shows how it was traditionally used in Rails and OpenStacks and Revs. And how it's now packaged, you have this Virt controller who reads the API server calls, and then it takes the actions to the node. There's a Virt handler sitting at each OpenShift node, making sure that whenever there's a request for a VM, it spawns up this VM pod, which consists of these friends we already know, this Virt launcher, Johan showed there. There's libvirt daemon inside the pod, and then there is the VM itself in the pod. And it's all within one container, one pod among the other normal container pods in the system. And this is how you see that which components are in the pod. If we look inside there, so the Virt launcher, it just loads the libvirt and sets up stuff, and then Gemu starts the VM. And then you have these connections to storage and network and CPU, and you can set the limits and whatnot, like in any virtualization system. And now, in addition to this, just running the VM under Gemu and such, you have the security defense in depth, like SE Linux I mentioned already, and KVM isolation and the friends. Let's look at the roadmap forward. So this was a quick view to the review mirror, what has happened. It's an old proven technology, and now what's going on forward. Red Hat is committed to take it further. We've been a major contributor in this KubeVirt, and now we have it in our roadmaps like any other project. It will follow closely OpenShift release model, and the new OpenShift release will bring new features likely to virtualization as well. I don't go into details in this roadmap. I just want to highlight that we have such. It's a developing technology, and we put effort into it, and we will make it good for you. At this moment, it already has the basic features of any virtualization platform, but there is still yet many to come. Like, for example, specifically for the telcos, they will need a lot of like networking features added and such, and they will follow. But at this moment, it's already in a basic usable level. And this, in short, is like a kind of recap what we already did. I'm not going to go over this slide, just going to mention it, that it has a roadmap both backwards, also forwards. And how you get going with that, You pick up your phone, you call to Red Hat, please bring us the kube virtualization onto our OpenShift, and our services will help you. So contact us. See you there. Thanks.